All right, so the next one. After we list all of our possible rational roots, we look at our calculator to figure out, of these possible ones, which one are truly rational roots for this function. It was -3. So we synthetically divide by -3. This is our check step. We better get 0 here. And in this case, we do. So this is my x, this is my x squared. This one does not factor, and it does have a middle term, so you have to use the quadratic formula. Make sure when you use the quadratic formula, if you're using your calculator to aid you with this, that you put that -2 in parentheses. If you're just squaring -2 in your head, you're going to get a +4. If you punch it in your calculator, the only way you'll get a +4 is to put that -2 in parentheses. So when we do that, we get the square root of 12. The square root of 12 is 4 and 3. So this becomes 2 plus or minus 2 roots of 3. And when I divide both the 2 and the 2 by the 2, I get 1 plus or minus root 3. Okay, so this is a little ugly. When I do the complete linear factorization, it looks like this. F of x equals, this first one becomes x plus 3. Because when we do the factors, it's always the opposite. It's x minus the root. Okay, so that becomes x plus 3. This becomes x minus 1 minus root 3. And then we have x minus 1 plus root 3. That's the complete linear factorization. This is somewhat meaningless to us. So you might find this one best to go back to that factored over the set of integers, which is where we go back up a step from these radicals. And so the factored over the set of integers would look like this. X plus 3 times x squared minus 2x minus 2. Okay, let's take a look at 3 and 4. Now, on number 3, this time when we look at those possible rational roots, we get fractions. Okay? So we have to change our counting number with our table. Do you remember how to do that? So you hit second, and where's my calculator so I can see the button?
You do second or window?
Yes, you do. It's second and window. Thank you. Second and window, and that's where you can change your counting number for your table. On this one, it looks like 0.5 is what we would want to count by. And when you do that, you would see that 1.5 is a root. Whoops. And so because 1.5 is a root, we can synthetically divide by 1.5 or 3/2. You can do either way. You can write it either way. So you bring down, you multiply, you add, you multiply, you add, you multiply, you add, and this is our check step. We should get 0 here. If 1.5 is a root, if 3/2 is a root, then we better get 0. Okay, so we would move the 4 over, get x squared equals 2, so it's plus or minus 2. Okay, so when we write the complete linear factorization, we get f of x equals x plus root 2, x minus root 2, and then this 3/2, we don't write x minus 3/2. That's not an integer. So what we would do with this is you would take this x equals 3/2 and undo it. Multiply by 2, and then subtract the 3. So we get 2x minus 3. On the complete linear factorization, I would not count off, but on the factored over the set of integers, you would have to write it like that. If you wrote x minus 3/2 here, it would not be wrong. But if you wrote it on factored over the set of integers, it would be wrong. So we have to multiply this one back, and we get x squared minus 2. And here we'd have 2x minus 3. Let me take a time out real quick. I would like to tell those of you that did your homework how proud I am of you. I know the last 5 days have been a little crazy. They were super crazy at my house. So I imagine they were crazy at yours. I probably had a little extra crazy hosting the dance. And my mom ended up in the hospital for a couple of those days. So that added a little extra craziness to mine. But I am really proud of all of you that completed your homework. That was awesome. I know I talked to my kids 2 or 3 times, and they're like, yeah, Mama got it. Yeah, Mama got it. Yeah, Mama got it. I never checked, so I'll find out today. if they did it. But just kudos to y'all. Good job. Your test is coming up. This stuff will be on that test. Let's make sure that you get it and that you understand and that you know what's going on before I have to assess you. Okay? So if you're doing your homework and you're still struggling, I need you to talk to me. If you're not doing your homework, then you should probably talk to me about why that's not happening. If it's not happening because you don't know what you're doing, then let's fix that. If it's not happening because life's busy or you've decided you're not going to do it, I can't fix that part, but I sure can help you understand math. That's my job, so let me do it, okay? So if it's the understanding part, let me know. All right. And I keep closing this out. It's like I'm out of practice. Next one, the 4. The 4 was our rational root that we could see. So we divide by that 4. It checks. We get the 0 as the remainder. And then we have to use quadratic formula. This 8 breaks down into 4 and 2. So this is 2 plus or minus 2 roots of 2. Divide by 2. So when we do, we get 1 plus or minus root 2. Okay? So I'm going to white out some of this stuff so I can show you what the complete linear factorization would look like on this one. And the factored over the set of integers. So the complete linear factorization would be x minus the 4, x minus the 1 minus the root 2, and then the x minus the 1 plus the root 2. So it's going to change those signs, so you have to do them one at a time, but both times the 1 ends up being negative. Now, the one that makes more sense to us is factored over the set of integers, where we back up, and we would get the x minus 4, and what can I multiply this back and get? What I started with, x squared minus 2x minus 1. All right, questions about number 4? Okay. All right, let's take a look at, let's see, if I go down to 100%, can I see it all? Yeah. Okay, so let's take a look at 5 and 6. This one you can see 2. So you synthetically divide twice, and that second division starts with the answer from the first. And this is what we're checking for, 0, 0. If we get those zeros, that's our check step. That lets us know we're heading in the right direction. So what we're left with is this x squared minus 5. Move that 5 over, take the square root of both sides. So factored over the set of integers and the complete linear factorization. We'll start with the complete linear factorization. So it's x minus root 5, x plus root 5, x plus 1, x minus 2. And then factored over the set of integers is where I take this root and go back up a step. And so I get f of x. These two, when I multiply those back, turns into the back up a step. And then I get x plus 1 and x minus 2. All right, number 6. I synthetically divide twice, and we had to change that counting number again. This list of possible rational roots had a 1/2 in it. So on my table, I want to count by 0.5s. So you can see both of these. And then you get this. And then we solve. And this time we take a square root of a negative. And when you take a square root of a negative, what do you get? I. So when I write the complete linear factorization, it's x minus I, x plus I. This, in the complete linear factorization, this is okay. But on the next step, factored over the set of integers, we can't have this fraction. Now when we multiply this back, it gives us x squared plus 1. And then this, the x equals negative 1/2. When I factor it over the set of integers, I can only have integers. I can't have that fraction. So I have to kind of undo this. And that tells me that this factor becomes this, 2x plus 1. And this is x minus 4. Okay, I'm going to take a look at these last two. This one was the hardest, and some of you actually changed it when I asked you to on Friday, and others of you didn't. I could tell when I looked around. So that one wasn't working for you. So this is what I had asked you to change it to. Now, this one had thirds. So on your table, you would make it count by 1 divided by 3. Don't punch in 0.3, because that's not the same. Actually, the counting, when you get to the change by on your table, you would actually punch in 1 divided by 3.
How are we supposed to change it to minutes? Or sorry.
How do we know what to change it to?
The table? Okay, so this right here tells you what to change it to. So when we look at our smallest fraction, that's what we're going to change it to. So when our smallest fraction was 1/2, we changed it to 0.5. Here, when we look at this, my smallest fraction is 1/3. So that's what I'm going to change it to.
How are you supposed to change it to 917?
Uh-oh. Did I write the wrong thing on the board?
Yeah, I got 9.
You have
Yeah,
9?
9.
Well, then let's do it with 9. And let's just start this problem over. So this is supposed to be 3x to the 4th plus 9x?
Yeah.
Okay. And then everything else was good?
Yeah.
Okay. So that does not change this, and that puts us in a good spot where we can do one together. Oh, there it is. My pink calculator. All right. 3x to the 4th plus 9x cubed. Okay, if you did not work this problem, get out your calculators and let's all do this one together.
That's what it'll be.
Yes.
Where did so I understand you get the original looking at the table like where y equals where y equals 0, but where did you get the ones up there on the screen like without the table?
The one that's upper corner.
I'm not sure what you're asking.
Like how did you get those?
How did I get these numbers? It's all the factors of 10 divided by all the factors of 3. So the factors of 10 are 1, 2, 5, and 10. And then the factors of 3 are 1 and 3. So when we divide them by 1, that's where we get the 1, 2, 5, and 10. But then when we divide them by 3 is where we get the 1/3, 2/3, 5/3, and 10/3. Okay, so let me turn this on. And let's do this one together. Math team, math team, math team. No. Okay. Presenter. Have all you guys entered your equation? Yeah, I did change the equation. There we go. Alright, so I have entered my equation into my calculator, and then I wanted to show you how to change your counting number to 1/3. We talked about it, but now let's go look at it. So we have to hit second and window for table set, second and window. And we want to count by this time 1/3. So we'll do 1 divide by 3. And when I hit enter, do you see it automatically changes it to that 0.3 repeating, which we can't do on our own. So you have to hit 1/3. Okay? So now let's go look at the graph. I hit zoom 6 because I'm not real sure what I did on my graph last. Okay, so from the graph we can see it crosses here and it crosses here. So it looks like it's at -1 and positive 1/3 maybe. It's hard to tell. So let's go look at that table. And
What did you press against that table? Second graph.
second graph. Oh, it's not any of them. I think that's because I told you it was 9 and not 7. So you guys couldn't do this one, could you? Alright, so because I typed the wrong number up there, this one doesn't work. We can't see any rational roots. Even if I go up to 10, we're not going to see any. I'm sorry about that. That was probably troubling. You probably thought you did something wrong. But instead, I did something wrong. Because it looked like it was -1 and 1/3, and it's not. Because -1 gives me -2, and 1/3 gives me -7.6. So that was an oopsie on my part. I apologize for that. I bet if it were 7, it would work. Let's go back and change that to a 7. Oh, now it works. Yeah, I typed in the wrong number. Okay. Alright, let's kind of review real quick before we move on to what we're doing today. Get back to this. So the one I changed it to, this one did not work. 7 would have worked. What I gave you did not work. So I'm going to leave that right there. Alright. So what we've been doing is we've been trying to find all the roots of an equation. No, you already have all these. Or all the zeros of a function. Depending on how we look at it. Depending on how it's given to us or how we start. Now, whenever you're given an equation or a function, what would be your thinking process? What would you go through to try to find all of them? Well, the first thing you should try to do, which is kind of the first thing we did this unit, was factor. If something factors and it factors easily, that's our first route. We would always try to factor first. The second thing you would do, if it does not factor, is then you would do your list of all possible rational roots. Now, if I gave you this on a no calculator, and you couldn't check them by looking at the graph, then you could plug in those rational roots, possible rational roots, into your equation. And what do you get out if it actually is a rational root? 0, okay? Now, so then the third thing we would do is test those roots to see which one equals 0. Or, this makes you happier, look at the graph for the x-intercepts, because those x-intercepts are the zeros of your function. So we look at the graph, which then takes us to the table, right? Okay? And then after we either tested them without a calculator or we've looked at the graph with a calculator, the next thing we would do is use synthetic division. I guess I should write the word use. Okay, so we're going to use synthetic division to get it down to at least a quadratic. Okay, so we're going to use synthetic division to get down to a quadratic. And then the last thing we do is we solve that quadratic. Now, sometimes we can solve it just by taking a square root if there's no middle term. Other times we have to solve it by using the quadratic formula. So we would solve it by taking the square root if no linear term, or the quadratic formula. So those are our two choices. By taking a root or the quadratic formula. Alright, now, sometimes we could test all of our possible rational roots and none of them would work. Sometimes all of our roots are either irrational or imaginary. So, in that case, if I give you a problem that has no rational roots, I'll give you one of the roots. I'll either give you an imaginary or I'll give you an irrational root. Okay? So, let's practice what to do if given a root. And that's what tonight's homework is. Given an imaginary root, and these are our notes. Find all roots. Were there flying pencils? Huh? Alright, so we're just going to do some examples today. And example 1, I am telling you that 2i is a 0 of a function. And that function is f of x equals x cubed plus x squared plus 4x plus 4. Now, given the rules I just gave you, there's no way I would do this problem this way. Because I see that this is a very simple 4-term grouping problem. And that is the way I would do it. But I want to show you how we can start with this to find the rest of them. Okay? So what we would do is we would just do synthetic division by this number. But this number just happens to be imaginary. Now my coefficients are 1, 1, 4, 4. I'll go ahead and tell you, this looks crazy, but my students really like this because you automatically know if you're right or if you're not. They want me to take attendance. Good morning. They are, and I should have done that. Thank you. All right, bye-bye. Yeah, that's what they wanted. Okay, so when we look at this, same rules apply. We bring down the first one, we multiply. But when we add, it looks a little ugly. Because a real number plus an imaginary number you can't put together. You just write them side by side. It becomes a complex number. So, I will tell you it looks ugly in the middle, but it always works out pretty at the end. And that's how you know you're right. So, now we have to do this 2i times the 1 plus 2i. So when we distribute here, we get 2i plus 4i squared. But guys, what is I squared? Negative 1. So this really changes this to a negative 4 plus 2i. Okay, so you can already see some stuff working itself out. What happens to the 4s? They cancel. It's already clearing itself up. So now my next step is to do 2i times 2i, which is 4i squared. But what is 4i squared? Negative 4. And my first check step tells me I'm on my way. Now, the neat thing about irrationals and imaginaries, if positive 2i is a root of an equation, the negative 2i has to be. Its conjugate has to be. If square root of 3 is a root, then negative square root of 3 would have to be a root. So with our irrationals and our imaginaries, if 2i is a root, the very next thing I divide by, even though it wasn't given to me, I know it has to be a root, is negative 2i. That's the only way we can get them. Because to get the 2i, what happened is I started with this. And to solve this, I had to move this over. And what happens every time we take a square root? We get a positive and a negative. And that's why they are always both the positive and the negative. Even if I only list the positive, you know they both have to be roots. Okay, so this is when things get really pretty really quickly. Yes?
Is that always gonna happen?
That's an always. Yeah, we don't always have always in math, but this is one time. Okay, we're going to bring down the 1. We're going to multiply. And this is this next step. Once you divide by an imaginary number and its conjugate, your imaginaries will disappear. So, there they go. They're starting to go away. And then this times this makes negative. And we finish it off. Okay. So, this is my constant, and this is my x. So what I'm left with is x minus 1. Well, this is not even a quadratic. When I set this equal to 0, all I have to do is move the 1 over. I'm done. Oh, I don't know. Thank you, Caleb. Yeah, you're right. So my roots are negative 1, 2i, and negative 2i. Now, let's go back to that method I just talked about. This will seldom work in these problems I give you. But do you see I could group this? And then this would be an x squared and an x plus 1. And this would be a 4 and an x plus 1, which would give me x plus 1 times x squared plus 4. And what happens when I solve x squared plus 4? I just did it. Oh! I would get x plus 1 and x minus 2i and x plus 2i. So my roots are negative 1, 2i, and negative 2i. Now, like I said, seldom do they factor that nicely. Okay. We're on a homeroom schedule today, right?
Yes, ma'am.
Let's see, where's my homeroom schedule so I'll know when that bell is going to ring. And how many more examples I can do. I've got I got perfect time today.
What time do we get out?
According to my homeroom schedule, we get out at 9:44. Okay. I'm going to do one more with you, and then I'm going to give you time to work. Okay, so I'm telling you that this complex number is a root. And here's my equation. Okay, so looking at this, you wouldn't know how to factor it. This is one we couldn't factor, or we wouldn't know how to factor. Okay,
you only have 2 like this on your homework. So the first kind I did is the easier kind, and this is the harder kind. And you only have 2 of this kind on your homework. The other 6 are the easier kind. Okay? So, if 2 plus 2i is a root, then what also has to be a root? 2 minus 2i. So these are the 2 roots we're going to divide by. So the first one gets a little ugly, the second one cleans it all up. That's what happens. So the first one is 2 plus 2i, and then we've got 1, negative 4, 12, negative 16, and 32. And I always, when I know I'm dividing by imaginary, I space it out. Because I know when I do some multiplying and adding, I can have complex numbers and not just, yes sir?
To the right of the 2i, what is that?
That's just a semicolon. I was just not writing all the words. Okay, so we bring down the first one, and when we multiply something by 1, it doesn't really change. So now when I add, I get negative 2 plus 2i. So now I've got to multiply. So this is going back to practicing multiplying complex numbers. So when I distribute, I get negative 4 plus 4i, and then I get a minus 4i, and then I get plus 4i squared. But the I squared makes that a negative 4. So it is negative 8. Okay? So negative 8. And then I'm left with 4. So 4 times this is a little easier. I get 8 plus 8i. And so now I add the real parts, and I only have one imaginary part. Okay, so now I have to do 2 plus 2i times negative 8 plus 8i. And I get negative 16 plus 16i minus 16i, yay! And then plus 16i squared. But that I squared is going to make that a negative. These are going to cancel, and it leaves me negative 32. Check. It works.
Now we have to do one more.
Now we have to do one more. I'm trying to get this out of the way real quick. Okay, so we do it once again. This time we're going to do it with 2 minus 2i. And this is where everything gets pretty. We bring down the first one, we multiply, and we add. Yay! And we multiply, and we add. Yay! And we multiply, and we add. Yay! That second line is so much prettier than the first.
Yeah.
And that's going to happen every time. And so this is my x, and this is my x squared. So I'm left with x squared plus 4 equals 0, which is easy to solve. You don't even have to use quadratic. Move the number over, take the square root when you get the positive and the negative of that, and we get plus or minus 2i. So all my roots are 2i, negative 2i, the one I was given, 2 plus 2i, and then 2 minus 2i. And we found them all. They were all imaginary. Would this graph cross the x-axis?
No.
No, it wouldn't, because we have no real roots. It either all lives above or it all lives below, and because the leading coefficient is positive and it's even, the whole graph lives above the x-axis. Okay, one last thing. We moved worksheets around also because of our days off. So this says day 26 at the top. It's actually day 25. So I ran it off before we changed things. So please change the 26 at the top to 25. Please change the 26 at the top to 25.
This will be, you know, leave it.
I sure can.